Good morning everyone. So today we are going to learn the types of crystal lattice. Let us continue discussion about a unit cells. So earlier classification, that is a primitive type of unit cell, BCC, FCC, whatever we have discussed, it is entirely based on assumption that our unit cell is cubic in nature. But not necessary that a unit cell is having a cubic structure. So it may change its structure depending on a parameters. So the shape of the unit cell is decided by two factors. The number one is a edge length and second one is edge angle. So if I consider one unit cell, and let me consider this is the x-axis of the unit cell, this is the y-axis of the unit cell, and this is the z-axis of the unit cell. Now here along the x-axis, the width of the unit cell is called as edge length, which is represented along x-axis is A, that of along y-axis is a B, and edge length along the z-axis is C. So here A, B, C are the edge length of the unit cell along the x, y and z axis respectively. Then if we observe here opposite of x axis, that is the angle between y and z axis, so this angle is called alpha angle. So alpha angle is lies between two planes, that is yx plane and xy plane. So the angle between zx plane and xy plane is called alpha angle. Similarly, the angle between zy plane and yx plane, that is the angle opposite of this y axis, in other words the angle between zy and yx plane is beta angle, and the angle opposite of z axis, that is the angle which lies between xz and zy, it's called gamma angle. So the shape or the structure of the unit cell is entirely depending on these 6 parameters: 3 edge length and 3 edge angle. Edge lengths are represented as A, B, C, and edge angle is represented as alpha, beta and gamma. So by changing the relationship between edge length and edge angle, we can get number of types of unit cells. But out of that, a Bravias is a scientist who has converted and reduced that number of types into 7 systems. So now we are going to learn that 7 systems of crystal lattice, and in that 7 system of the unit cell, generally total it forms 14 types of lattices, that is we called as Bravias lattices. So let us see that different types in the next part. Yes, so let us discuss different types of crystal systems or unit cell. So as I said, there are total 7 crystal systems, and under these 7 crystal systems we are having total 14 Bravias lattices. So Bravias is a scientist who has consolidated the possibility or the consolidated the number of unit cells into 7 systems, and under 7 system he has suggested that 14 lattice structures are possible. For his work and his dedication, these 14 lattices are called Bravias lattices. So let us learn these 7 systems. Now to remember these 7 systems, I will use one code, because here we need to remember that 7 systems with the relationship of axial length and axial angle. So the 7 systems are cubic system, tetragonal system, orthorhombic system, hexagonal system, rhombohedral, which is also called trigonal system, monoclinic system, and at last triclinic systems. How to remember these 7 systems? Let me give a code for that. The code to remember this 7 system is Cuba's terrorist ordered hexane relative small h capital M capital T. Now how this one sentence will help us to remember all these 7 systems in a sequence. See, the first 3 alphabets, that is CUB, that is a cubic CUB, it stands for cubic system. Second one starts with TE, it is the hint for tetragonal. Now let me tell you, now in this particular total system 2 names are there which is the gonal type. One is tetragonal, next is trigonal. So to avoid the confusion, just you remember the first gonal means after TE comes, it is a tetragonal. Tetra means 4, so easy to remember. So tetragonal. Next one is OR, it is beginning for orthorhombic. Next one is HEX, that is for hexagonal. Next one, we have to combine this relative and H, that means I have to join this capital R of relative and small alphabet H. So the next system is initiating from RH. RH initiation is therefore rhombohedral, and since we are combining 2 words or 2 alphabets, it also gives us another hint that there are 2 names to this particular system. So this rhombohedral is also has another name, that is trigonal. Next one is a capital M, stands for monoclinic, and last is capital T, stands for triclinic. Okay, so these last 2 are the 2 clinics without doctor. Simple way to remember these 2. Okay, so these are the 7 systems. Now after remembering these 7 systems, now we need to remember and understand the relationship of axial angle and axial length in these 7 systems. So how to remember these? Okay, there are some simple hints I will give you all. First, we know that cubic system, in case of cubic system, all the 3 sides are equal and all the 3 angles are equal, and which is equal to 90 degree. So in case of cubic system, A equal to B equal to C and alpha equal to beta equal to gamma, and which is equal to 90 degree. So cubic system is very easy to remember, everyone. Once you written this cubic system, exactly opposite of this will be triclinic. Okay, here all are equal, here all are not equal, that's the difference. So triclinic, A is not equal to B, not equal to C, and alpha is not equal to beta, not equal to gamma, and also not equal to 90 degree. So now out of 7, 2 we have remembered with perfection. Now let us see how the remaining 5 will help us or can be remembered in a easiest mode. So now let me consider the beginning one. So in the first 3, see, in the first 3 the relationship of axial angle is the same, that is first 3 alpha equal to beta equal to gamma is 90 degree is a common for all the 3, that is a tetragonal, orthorhombic and cubic system. So we have to change something under axial length. The first one, all three sides are equal. So second one, I will make A equal to B but not equal to C, and to make a different than first two, under orthorhombic, A is not equal to B, not equal to C. Okay. So now out of 7, cubic easy to remember, triclinic easy to remember. With the help of cubic, I have explained how can you remember for tetragonal system and orthorhombic system. Now the question is how remaining 3 it is to be remembered. To remember the remaining 3 under the axial length sequence, the things are very simple. Whatever we have written axial length relationship under triclinic, same thing is applicable even for monoclinic. And by bypassing this orthorhombic, tetragonal relationship of axial length will be applicable even for hexagonal, and cubic relationship is applicable for rhombohedral. So this is how the axial length of all the 7 systems are easy to remember. Now we have remembered axial angle of first 3 system and last system. Now when I say a fourth system, that is hexagonal, so the first structure or one of the simplest molecule of organic molecule which is having hexagonal structure will come in a mind is a benzene. And everyone knows in a benzene one of the angle is 120 degrees Celsius. That is the internal angle of hexagon is always 120 degree. So if you remember this one hint, then the relationship of angle is very simple. That is alpha equal to beta is equal to 90 degree, and one of the angle is 120 degree. Now the rest two angles in case of rhombohedral, alpha equal to beta equal to gamma, but it is not equal to 90 degree, and in a monoclinic, alpha is equal to gamma which is a 90 degree, but beta is not equal to 90 degree, also it is not equal to 120 degree. So these are the 7 systems we have discussed with their axial length and axial angle relationship. Okay. So now let me tell you these 7 system contains or they show total 14 Bravias lattice. Now let us consider, or let me use some symbolic representation. P stands for primitive or simple type of unit cell, B stands for body centered unit cell, capital F stands for face centered unit cell, and E stands for end centered unit cell. So out of these 14 crystal lattices, primitive type is present in all the 7 systems. So all the 7 system P is written, means out of 14, 7 systems are primitive type which occupies in all the 7 systems. Okay. Second one is body centered unit cells. So now remaining 7. So out of 14, 7 are primitive. Now remaining are 7. Out of 7, 3 are body centered which occupies position 1, 2, 3. So B, 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 you can observe in the first 3 systems which shows body centered unit cell. Now remaining 4. Out of 14, 7 plus 3, 10 are over. 4 are remaining. So 2 are under face centered, 2 are under end center. So this face centered will be position 1 and 3. 1 and 3 position, and end center will be 3 and 6. So 3 and 6 positions in the table. So this hint will help you to understand which particular system will form how many types of crystal lattices. Okay. The example of cubic systems are zinc sulfide or sodium chloride. Tetragonal system is zinc oxide, titanium dioxide. Orthorhombic system is rhombic sulfur. Hexagonal system is graphite. Rhombohedral or trigonal system examples is calcite or arsenic. Monoclinic example is monoclinic sulfur, and triclinic example is potassium dichromate. So we have seen a different types of unit cells. Their structures you can observe in this particular slides. Here a notation slightly we have changed. P stands for primitive, I stands for body centered, F stands for face centered, and C stands for side center or end center. Okay, you can observe here under the cubic we are observing three types of unit cell. Under tetragonal 2, orthorhombic these 4, hexagonal 1, then monoclinic will form 2, triclinic 1, and trigonal 1. This trigonal itself is nothing but rhombohedral. So if we follow these relationship, so these are the different shapes of or structures of unit cells we are going to get. Thank you.